You're going to have to watch Rodney Jr. learn to go forwards and backwards. Is there any way we can get a picture of this down with? It's not going to go like that. Don't have any cameras up here. Anyways, so this is Rodney Jr. Rodney Jr. is a machine learning robot. Basically, what he tries to do is keep moving, okay? If you look at differential drive, the only two motion patterns within any magnitude or displacement are forward and reverse. Everything else just goes around a point. And I've got a little Roomba motion sensor here with a emitter detector. And as long as the robot's moving either forward or reverse, he's happy. When he is in a motion pattern and he encounters a stall, he tries something that makes him move. If it's successful, he increments the confidence. If it's not successful, it decrements the confidence. And in the gamma, or the third level, when it encounters a stall condition for a motion pattern that it doesn't have any high confidence responses, it tries other high confidence responses before reverting back to random motion. So let's see if Rodney can, is there any way we can get the, okay. Yeah, that's good. That's good enough. So here he goes, his random motions. He's got little lights on him. The light's green, he's happy. When the light's red, he's not happy. He's stalled when it's red, and he's moving when it's green.
Or me demoing the
Yes, jokes,
most recent?
yes.
We want joke telling and the most recent. Right?
Yeah.
We'll try this one more time here. And if this doesn't work, I'm blaming on low batteries. Not lighting. Okay, there you have it. It's not that the robot's going back and forth, it's that it learned to go back and forth. All right, that's that. Bring more robots next time. Maureen, you want to tell us about your end mode? You still setting up?
Oh, no, I'm ready.
You ready? You want the microphone? Maureen Davis, ladies and gentlemen.
So I just disconnected the up-down motor. So I learned this before, but if you put it up too much, the screw will actually come out, and so I had to be careful about that. But right now, I do have this one working, so that's great. And right now, it's on autonomous, so it's just moving around. So since last time I came to Homebrew, I was working on this, and it took a long time, but I finally got the thing moving. I got it lubricated, I got it connected, and so I got this turning one first. And so after that, I put this motor in, and I screwed it in, and I got that working as well. I had some trials and errors, and eventually I figured it out. I got it working, but it's not working right now. Well, that's fine. Any other questions?
You'll have it working in October?
Yes.
Very good.
The what?
The brake pieces for the shoulder, how long did that take?
I printed it a while back, way before I built it, because I always do that. But usually some of the bigger parts would take like 2-3 hours ish, or some would only take 1.
Can you tell a joke?
No, it doesn't have the Raspberry Pi connected.
Okay, no problem. He'll tell a joke in October. Maureen Davidson, ladies and gentlemen. Hey, Daniel, you want to give away your 3D printer?
Just quickly, so I have a 3D printer, an old 3D printer in the corner. Last time I checked it, it worked, but it may have suffered from storage. So if anybody's interested, I want to donate that. And I also have a box with lots of different filament, PLA, ABS, all kinds of colors. So all for donation if anybody's interested. So yeah, that's all I need.
Daniel, talk to Daniel.
Yeah.
All right.
So back last year in October, when I first started off with Homebrew Robotics, I was showing off this new script that me and my team were working with. It was just me and another guy, and we were showing off our motion control software for controlling robots with animation. Well, fast forward to today, where we actually got our script fairly competent right now. We're actually able to export animations files from our software and actually put them on top of our robot. So I had a test over the summer for my, I'm going to call them interns. I had an animation student, I had a computer programming student working with me. I was doing the engineering for some of the robots, and I had a few other visual development students working with me. And so we made a short film using the robotics and animation motion control software. So I wanted to show off a little bit of it tonight. This is the first time I've ever bringing it out in the public, so thank you guys. I'm sure there's any sound, but there's supposed to be sound.
Sound on your local system there. Put the microphone to it.
Is there sound?
Gotta plug it in.
That's a tuner. Right here. There we go.
Phase 4.
Still working.
All right, so there we go.
Give me a second to get back there, and I'll bring it up.
It's just some technical difficulties.
Thank you, Google.
Yes, thank you.
That's not funny.
So as I mentioned before, all of the motions for this robot was fully animated. And we actually took CGI motions from Maya, and we were able to actually play them back through the actual robot. So new animation form, we're looking at new different kinds of short films we want to do. I have an environmental related film I want to tell with this technology in a little bit, but it's still a work in progress. We're still improving a lot of things, but yeah, storytelling with robots. Thank you.
So you'll recall that I mentioned last month that I was trying alternate materials for the axles and for some of the structural parts, and in short, they don't work. It appears that the nylon is not as strong as I had thought, or at least it
You were
is,
sure
but-
bragging on it last month.
Yeah, it was, and it loaded into the car fine, and then when I set it down here, it broke, and then another part broke, and what's really interesting is that the solid stuff, the parts that are 100% infill, so like this part over here broke, like the rocker broke. I was like, oh well, that's because if you look at it, you can see like there's an infill pattern. So apparently I'd forgotten I put a one that wasn't completely filled. And then the steering knuckle broke. And I was like, wait a second, that one is 100% infill. So I think the nylon is just not strong enough. I've noticed that it deflects. And I noticed when I got it home and I was actually like starting to look at like how I'm going to connect the wires and everything, that it was kind of sagging a little bit. Yeah, gonna take it home, fix it. I have, I'm gonna be hanging out at circuit launch a lot more over the next couple months, which is good news. So they have a machine shop. I should be able to actually cut some metal, and I also have a spooled PC, polycarbonate. I'm gonna try and print the axle parts out of that. That's actually one of the great things about 3D printing is like once you get the model down and you get your tolerances and everything, you know, straightened out, you can just kind of go to town on whatever material, you know, if something better, new comes along, print out the same model, just a different element. So this is kind of where we are right now. You know, it's an experiment. I always said it was an experiment. And it was a new way of trying things. The other interesting thing is that you'll note is that these right here, the wheels themselves, the motor pods, the axles on the motor pods, those are great. Those are fine. I think that's because they are supported and suspended. You know, it's the same material and it's still like a long thin shaft, but you've got like support here. It's being gripped on. There's like a lock washer, or I'm sorry, there's like a locking thread back here. It's a locking thread right here. It's screwed down. It's kind of beings rather than like the steering knuckle right here where you have this long shaft. There's like just steering all the weight. This one right here is fairly well sleeved, and so it's kind of being supported all the way along. So, anyways, that's just a quick update. I'm going to take this back home and fix it and figure out what to do. And, more soon.
Hi, sorry for the technical difficulties. Again, I'm Alan Fetterman. I wear many hats. Sometimes I think I'm like Bartholomew with 1,000 hats. Besides working with Ubiquity Robotics and Stanford. I got tagged last as Greg Maxwell went out of town, and I'm a co-organizer with Gloria DeFelix for SV Ross. And since I just moved out of the area, Camp has been standing in for me as pseudo junior organizer.
Trying to. Big shoes. Big
Well,
shoes.
Yeah, big pants too. Anyway, so one of the things is, this is a builder's club, and sometimes when you start off, you don't have a robot. However, what the big boys do, what the big companies do, is they often run things in simulation. And Ross has a lot of simulation tools. One of the most sophisticated is called Gazebo. And we mostly use RViz, but Gazebo can model robots as well as physics, and you can actually run a script that runs on a real robot, but you can test it out in Gazebo. So this is a program, a script, and it's everything here is open source and can be downloaded. So the script is from Patrick Goebel's book, Ross by Example, and this is a script that just makes a square based on odometry. And the thing is, once you run it in simulation, and the way it runs in simulation is the way it'll run in the real world, even to the fact that there's physics. So even though I told it to make a 90-degree turn, it's not going to be quite a 90-degree turn. And the reason I think is because there's physics, and it's a differential drive robot, but it has casters in the back, and the casters do a little drag when it turns. So it's not quite as, it's not quite 90 degrees, it's turning a little bit more. I think it's the momentum of the swing that's knocking it out. So it's 92 degrees.
Well, the actual robot swivel, the casters swivel, don't they?
The casters swivel, and I don't think the casters are modeled well. And the thing is, this has real physics in it. So you can take an object there. This is really cool. And then run,
Are you going to push that?
yeah, I'm going to push it. So people who know Ross know what's going on here. So I'm just going to,
Totally off to his keyboard.
so now I push the ball, and since there's momentum, the ball is going to continue to roll off the screen. So yeah, I'm amusing myself here. So the thing is, this is using open source. This is if you go to GitHub, Ubiquity Robotics, you can download Magni Robot, and the Gazebo simulation is in there. You then do a full desktop install of Ross. This is Ross Kinetic, and you can run the scripts. This is the what we call our empty world script. I've actually modified it so it can be controlled by voice commands. Unfortunately, I can't do voice commands in this venue because something about Google not allowing certain ports to be open. But I can do a demo of that.
Oh, you made a video. Ah, that's smart.
This is the wrong video.
Yeah.
This is the old one. I have one that actually has voice commands working. Let me get that.
Yeah, yeah.
Looks promising.
Rotate left. Rotate left. Rotate right. rotate right, forward, forward. Okay, now I'm going to execute a script. See, I always film my demos because you never know. The script is to make a square. So we drove out a meter, turning left, driving a meter. When you listen to your own voice, you sound so turning left, ignorant. Driving another meter. Okay. Turn. So the other thing, so everything is downloadable in your Catkin source. The Magni robot is in the GitHub for Ubiquity Robotics, and the other scripts are Ross by example. And I forget, I think that's PyRobot, is P-I-R-O-B in GitHub. That's Patrick Goebel's scripts. And also that book is the way I learned ROS and running those scripts. So, okay, that's it. Thank you. So if you don't have a robot and you want to learn ROS, you can have a simulated robot, and you can also do the same thing with the SVROS robot or a TurtleBot.
All right, thank you very much. Doug, come on down.
Hi.
Ross by example.
So my goal here is to build a robot that can do something functional. My interest is in creating behavior strategies, but in order to demonstrate it, I want to create a platform, and I chose this agricultural robot. My goal is to pick up strawberries, and it's more complicated than the repetitive industrial robots that I've been working on for the last 20 years, but it's more doable than like a human interactive robot that I don't know how to do. So what I'm going to do is there's a 2-axis delta arrangement. I don't have the third axis, so it depends on the robot movement to do the third axis. So if it works right, which it might not, it will see the berry with a stereo camera, and it'll move the arm over over where the berry will go through, and then it'll try to close the gripper as the berry goes through it.
There's a strawberry down there.
There is a plastic strawberry down there. So we'll see how this goes. Sorry. It works in my backyard. I should have made a video like you recommended. My goal now, when it works with a color block, and my goal actually is I bought one of those little coral sticks from our friends at Google, and I want to start to use convolutional neural nets to find the berries. But it's coming together. I do have the one trick is the kinematics of this Delta robot arrangement. That's kind of fun. And then you can see that the stereo camera is at that kind of funny angle. So there's a transformation between so when you buy one of these stereo cameras from this one's from Stereo Labs. It's a Stereolab Z, and they give you the equations for resolving something in 3D space, in Cartesian 3D space, but then you still need to transform it to be in the coordinates frame of the arm so that you can pick it up. So I've been working through those things, and that's all working pretty well. But the hard part is obviously the finding something in a random environment. So,
What is the problem here? Lighting, do you think?
yeah, I think it's the carpet, actually. It's different than the cement in my backyard. And I thought that I fixed the exposure of the camera after I failed so miserably last time, but obviously I still got something.